Hello everyone, my name is Ray Aslan. I'm an instructor at Fortinet. I teach the public cloud security course, and during the public cloud security course we have labs where we deploy FortiGate and FortiWeb into AWS and Azure. Today I'm going to do a lab demonstration for you for how to deploy FortiGate into AWS. Today will be a multi-part lab. It's going to be broken into several recordings, but for this very first lab, we have a very simple topology that we're going to deploy. Let's bring up a picture from the lab guide. Here we go. And let's turn on some drawing tools so that we can draw over here. All right, so what we're going to do is we're going to deploy this VPC that we see here. There we are. In this VPC, we are going to deploy two subnets, a public subnet and a private subnet. The public subnet is going to use 10.0.0/24. The private subnet is going to use 10.0.1/24. This is all part of the VPC, which is 10.0/16. Now within this VPC and these two subnets, we are going to deploy a FortiGate. Let's pull down. There we go. Let's erase all of that. This FortiGate right here is going to have two elastic network interfaces in here. We've got one that says port 2 and one that says port 1. Basically, there's an ENI plugged into each subnet. For each subnet, there will be a separate routing table. The public subnet will use this public route table. The private subnet will use this private routing table. The public routing table will direct all traffic to 0.0.0/0 to go outbound through the internet gateway. So we'll have a route in there like that, a default route that says you can go out through the internet gateway. The private routing table will tell the VPC to direct any unknown traffic or a default route outbound through the FortiGate. And so our FortiGate is going to act as a gatekeeper between the public and private subnet, where we can deploy outbound policy allowing a Windows server that will exist in the private subnet to get out to the internet, or have an inbound policy with a VIP that allows RDP traffic from the internet to come in and get to the Windows server. So we will have a policy that allows traffic that is destined for an elastic IP address that gets destination NATed by the internet gateway to the FortiGate, and then the FortiGate will have an RDP policy with a VIP, a virtual IP, that allows that traffic to get to the Windows server. Well, that's what we're going to deploy. Let's go ahead and erase our drawings there and get started on that deployment. Let's set ourselves back to a mouse pointer. There we go, we'll pull this over here. As you can see, I'm already logged into the AWS Management Console. I'm looking at the list of all of the services with all the different types of resources that I can create. And we're going to start off with creating the networking first. So we'll go and create the VPC. All right, now I have an account that I just use for training purposes. I use this to teach classes, do demonstrations, and that's all that I do with this. So if you look at my account, I'm currently pointed at the US East 2 region, or Ohio, where I'm going to deploy everything today. There's really no resources currently created. I don't have any VPCs, any subnets, any route tables. There's really almost nothing here. And that makes it really easy for me to work on these labs because I don't have to get worried about being confused by other VPCs or other resources or services that I've already deployed. If you are learning, that's not a terrible idea in terms of how to learn. Create an account for yourself, tie it to a payment method, and come out and start creating resources. That way you know that the resources or services that you create won't interfere or be confused by other resources or services that you've already created for production purposes. At the top of the VPC screen, we see Launch VPC Wizard. That is one way that I can create VPCs and subnets and route tables. That wizard will create a bunch of different services or resources for me. I don't actually want to do that. I don't want to have all of that automated. I want to demonstrate doing it for you manually. So I'm going to go through these one at a time. I'm going to create the VPCs, the subnets within the VPC, the routing tables that work with the subnet, the internet gateways. All of these things will be done individually. It is also worth mentioning that if you're following along in your own console, you might see slight differences between my console and your console. One common reason that this comes up is because AWS likes to put in options like this. When they've improved some console screen, they'll give folks the option to opt into that new version of the screen or opt out of it. So you might log in and be using the new VPC experience, and at first glance, you go, well, that basically looks just like the old one. It does look pretty close, but there are some subtle differences, and it might change some of the steps. You might have slightly different steps in some of your screens. I'm going to go ahead and turn mine off. You can turn yours on or turn yours off. Honestly, once you get to know what the actual options in these screens do, the change in the GUI is pretty minor in terms of impact. Let's say, yes, I was satisfied with it. I just don't want it. There we go. But if you notice a difference between your screen and mine, go look for something like that. Usually those options are either at the top of the screen or perhaps up in the corner somewhere. Let's go ahead and, yeah, there we go. This option right up here, new VPC experience, which I just flipped off. Let's put ourselves in non-drawing mode. All right, first, let's start off with creating our VPC. Oops, I clicked on zones. That was an accident. All right, virtual private cloud, your VPCs. I shouldn't have any right now. Okay, I don't. Let's go ahead and create one. I'm going to call this Lab VPC. That'll work right there. I'm going to use the CIDR block that the lab diagram indicated, which was 10.0/16. That is the largest CIDR you can use. And we'll go ahead and just create that. Now, when I created that VPC, I gave it a name, Lab VPC, because I'm going to use it for the lab. That name is for the human beings. That's really not for AWS to identify that VPC from any other VPC. Every resource or service that you create gets an identifier. And the identifier usually has a format that looks a little bit like this right here. It is usually an acronym and then a hyphen and then some alphanumeric unique identifier. And that's mine right there. VPC is the acronym, which guess what? It's a VPC. And then this fairly non-intuitive alphanumeric identifier. There may be screens that come up that don't list a resource's name or description because those are really, as I said, for the people, for the humans that are interacting with the system. So from time to time, you might have to go back to your list of VPCs, and I'll go ahead and click OK, there we go. And you might actually have to note the actual VPC identifier, not the name, because maybe you've got 10 VPCs and the drop-down list on some other screen only shows you the VPC identifiers. Usually what I'll do is I'll just note the last 5 or 6 characters of the identifier. I might say Alpha Delta Echo 80 Fox 9 ADE 80F9, and I might jot that down so that later on some other drop down I could note which one this was. I'll show you a little example of that later, but just heads up, as we create resources, we will see these identifiers pop in, and remember, those are the real identifiers for the resource or the service that we've created. All right, well, there's my VPC with 10.0/16. Let's go ahead and create some subnets. I said there were 2 subnets. One was called public, one was called private. Let's click create, and we'll call this one public. Again, that's a name for me, nothing really for AWS. There's only one VPC that this subnet that I have on my account right now, the subnet can exist with. It's called Lab VPC. Availability zone. Now, every subnet ties to a single availability zone, a single AZ. Right now, I don't really care which availability zone it chooses. Later, I'll have some different labs in other videos where I'll show you some redundancies with different availability zones. But for right now, this will be fine. that is the CIDR of my VPC, so my subnet needs to be part of that CIDR. We'll just pick the 10.0.0.0/24 subnet CIDR. We'll create that. There's my subnet identifier, click close, and I'll do the same thing again for the private subnet. Well, first I'll learn to type. There we go. Choose my VPC. I'm not going to choose any particular availability zone, 10.0.1.0/24. There we go. There's my subnet identifier. Click close. I've got a public subnet and a private subnet. Now coming back to our diagram that we were looking at just a second ago, right? Let's go ahead and bring up a pen so we can draw here. I've created this subnet and this subnet. Internet gateway. I'm going to create an internet gateway resource, and this is going to allow outbound traffic to the internet or inbound traffic from the internet into the public subnet. Now, in order for that to actually occur, I'm going to have to assign a resource, a public or an elastic IP address. So right now, I'll create the internet gateway, and then I'll create the routes to support this inbound and outbound traffic that I've just written in here with these very lovely artistic red arrows in and out. Yeah, I work in IT, I'm not an artist. All right, let's go ahead and get rid of those arrows, erase all of that, and give myself back my mouse pointer. Very good. The Internet Gateway object will be in a routing table, so let's create the Internet Gateway first, and then we will create or edit our routing tables. Well, creating an Internet Gateway, how difficult is it? Click Create Internet Gateway, give it a name. Lab Internet Gateway sounds good to me. Let's just say Lab IGW. Click Create. It's exactly that difficult. And as you can see, there's our identifier, IGW, string of unique alphanumeric identifier there. Now you have to create it, and then you have to attach it to a VPC. Let's go ahead and attach it to a VPC. I only have one. And you'll notice the name shows up here, but when I actually choose the entry, it's using the VPC identifier. You'll become accustomed to that. As I said, those names are just for people. AWS doesn't need those names. We do. It makes our lives easier. All right, there we go. I've got my internet gateway. Now I need to work on routing tables. First thing that you need to understand about routing tables is every VPC already has a routing table by default. It's called the main routing table for that VPC. And if I click here, I see there's a routing table that has no name. It does have a routing table identifier, and it says main yes. That routing table for that VPC only really has one routing table entry. It is a routing table entry that tells the VPC if something goes into a subnet and is destined for 10.0/16, which is my VPC's CIDR, just send it directly to that other resource. So this is basically a routing table entry that allows all of the elements inside of the VPC to simply route to each other directly. I'm going to make this a private routing table. So I'll have to edit it a little bit later and tell it to route things to the FortiGate, but I don't have a FortiGate yet, so we'll just leave it the way it is. Let's create a second routing table. We'll call this one the public route table, or there you go, public subnet route table. Actually, no, let's take that subnet out of there. All right, which VPC? Well, I only have one. And let's click create. There's my new routing table, my identifier. There you go, public routing table, private routing table. Let's go look at this public routing table and let's think about this diagram again. Let's get my pen back here. There's my pen. So this public routing table needs to have a routing table entry that says if something goes into this subnet and the destination IP address is a default route, is 0000/0, send it out to the internet gateway, which will then take it out to the internet. There's already a routing table entry there that says for 10.0.0.0/16, the complete VPC, just route things directly. Everything else, I want to go out the internet gateway. Let's go create that route. So erase all of this and go back to a normal mouse clicker. There we go. Public routing table, we're going to say edit routes. I'm on, you'll notice there's summary tab down here, routes tab down at the bottom, edit routes. Let's add a route. Here we go, 0000/0. Where do you want to route things if they're destined for anything? Let's tell it to go to the internet gateway. It'll ask me, great, which one? That one. I only have one, but if I had several, luckily that shows the name. Save the routes. There we are. AWS routing tables are like on-prem router routing tables. Any routing table that you've ever used on a traditional on-prem piece of equipment. The most specific route always wins. And so here I have two routes. I have a 10.0/16 route that says target local, which really just means if something's destined to 10.0/16 or the CIDR of the VPC, just send it directly to that other resource. Things can route directly inside of my VPC. However, if it's for anything else, this is the least specific route you could possibly make, right? A default route or a wildcard route, if you've called it that before. Send it to the internet gateway. Now, I made this routing table. I called it the public routing table. Obviously, well, I think it's obvious. My intention is I want this to be used for the public subnet. But by default, if you create a new routing table, it's not actually associated with any subnets. All of the subnets of the VPC, by default, are associated with the main routing table, the one that was created by default that I renamed private route table. So if I go to subnet associations for the private route table, you'll see the following subnets have not been explicitly associated with any routing tables and therefore are associated with the main routing table. And there it is. And as you can see here, let's pull this over. There we go. It's a little easier. It's the private subnet and the public subnet. So basically what I want to do is make the public subnet not use the main route table. Use it the other new public route table that I've created. I don't want it to use this one up here. I want it to use this other one. So we're going to go and get it. There we go. We're going to go to subnet associations, edit subnet associations. Actually, let's hit cancel real quick. Before I do, it says you do not have any subnet associations. All right, now let's click edit subnet associations. Let's get the public subnet. And if by the way, if you go to this screen and you can't see which one's public and which one's private and you forgot what the CIDR was, just grab that column and drag it over there. There we go. Let's click save. All right. Now we'll drag this over here so we can see it really easily. So the public routing table, RTB030D9975479F1438B. Yeah, that's a really long name. It is currently associated with the public subnet, and I'm not going to read that number aloud. So the private routing table, and remember, that's the main one. That's what was created with the VPC by default. It says the following subnets have not been explicitly associated with another routing table, therefore they're associated with the main. So it only has the private routing table. And the only route in it right now is that local route. Later, I'll make an adjustment to this. After I deploy the FortiGate, I'll create a default route that says send traffic that's going to anywhere that's not in the VPC, send it to the FortiGate instead. All right, so we have our VPC created, we've created two subnets, and we've created two routing tables. And one of those routing tables, the public routing table, is using the internet gateway for access to 0000/0. All right, well, that's a good place to start. Now we need to start deploying some things into that VPC. Coming back to our diagram, we're going to deploy that FortiGate that we see there in the middle of that diagram. This one right here. When we deploy this from the marketplace, it's initially only going to include one elastic network interface, which will be port 1. After the fact, after I've deployed it, I'll add a second ENI to it that will plug into the private subnet. Let's go deploy that now. Erase all these drawings. Go back to my normal mouse clicker, minimize. Right. So for that, we're going to go to the EC2 console. So we'll go under Compute, EC2, or I could have used the search bar at the top to search for EC2. I would have found it that way. Once again, we have one of these slider bars in the top left-hand corner that allow me to turn on or off the new EC2 experience. I'm going to go ahead and flip it off. I don't know if yours is on or off, but since I noticed it, I'll be explicit about it, and I'll say, yeah, I'm satisfied with the experience. Just don't really want it right now. Click Close. Before I create this FortiGate, there are some other things that I'm going to need as I create different resources. I'm going to need a key pair. Let's go ahead and create a key pair. So this is down on the left side, key pairs. I'll use this a little bit later to decrypt the Windows password. As you can see, I've created a couple. I want to create something specifically for our lab. Let's go ahead and click Create. And if you didn't catch that, it downloaded a PEM file. I'm going to use, the reason I created one specifically for this is I'm going to delete it when we're done, and I actually use these others for other purposes. So here we go, lab key pair, there it is. It's in my downloads folder. Let me go ahead and grab that. I probably have lots of different things in that folder. Let's go ahead and cut and create a subfolder for it so it's easy to find. AWS key pair. I'm sorry, I'm doing this on my other screen. I'm just creating a folder in Windows. Nothing too mysterious about that. Here we go. It's in its own subfolder in my downloads directory, labkeypair.pem. Very good. All right, now let's go back and launch an instance. There's lots of different ways that I could do this, and there's less variation when you click Launch Instance. I could go to Instances and click Launch Instance. I could click Launch Instance right here, and I basically end up with the exact same wizard. So I'm less concerned about how you get to the Launch Instances button. All right, now let's search for an instance. I'm going to say Fortinet. That should cut down my options. And then I'll say AWS Marketplace. So there we go. I'm going to use this pay-as-you-go instance right here, Fortinet, FortiGate, Next-Gen Firewall. It's currently at 6.4.2 release. It says I'm going to deploy something a little bit earlier. The version of the class that I'm doing this recording for, the most appropriate version would be a 6.2.x version. There may be a newer version of the public cloud security course later where 6.4 is the version we're deploying, but for what we've got in the course right now, 6.2 makes the most sense. Let's go ahead and click Select. Now, because I just clicked Select, it wants to deploy the latest 6.4.2 version. I don't want to do that. So instead of clicking Continue, I'm going to say View Additional Details in the AWS Marketplace, and this will let me pick an older version of the code of FortiOS. All right, very good. Let's go ahead and click Continue to Subscribe in the top right-hand corner. If you have not previously agreed to the terms and conditions, instead of this screen down here that says when you last agreed to it, you'll have some type of some type of clickable function that says, yes, I agree to the terms of service. And as I recall, it takes a few seconds before it'll actually come up and say, yes, you have agreed. So I don't need to click that. It's already been agreed to, but you won't be able to click continue to configuration until you've chosen that down here in this section. I've already done it. So let's just click continue to configuration. Very good. Let's choose a 625 is out there. That just deployed. So it's September 8th, 2020. I haven't used the 625 version in AWS, so we'll go ahead and choose that. It'll ask you which region you want to deploy into. Now, this is really important. When I was over here in the console, everything that I was doing was in the Ohio region or US East 2. I created VPC there, 2 subnets, routing table entries, all of those different resources that I created earlier were all in Ohio. When I switched over to the marketplace, I'm no longer tied to Ohio, so it will let me choose a different region. If I do choose a different region, I won't be able to find certain options in the menus that it goes through the wizard. I won't be able to find the VPC that I've already created because those aren't in North Virginia. Those are in Ohio. So let's go ahead and click the drop down and choose US East Ohio. If you're following along on your own and you're doing this lab, this is some place that people make mistakes a lot. They accidentally take the default, start deploying into Virginia, and then in the screens that follow, some of the options don't match up. So let's just say US East Ohio, save ourselves from a little bit of trouble. Continue to launch. And let's make some changes here. First of all, this is a small lab. I do not need a C5 extra large. I need a very small instance because I don't want this to be overly expensive unnecessarily. So T2 small, 2 gigs of RAM, 1 CPU, that should be fine for our purposes. It asks me which VPC do you want to use? Now, I only have one VPC. That makes this very simple. You'll notice that there is no VPC name, only the VPC identifier. If I had multiple VPCs, I would have to go back to the console, go to the VPC console, look at the name of the VPC that I wanted to use and look at its identifier, and then I'd have to pick in the list. And that can be a little surprising. Fortunately, I only have one, so that's the one. Similarly, my subnets had names like public or private. When I look at the subnet list, this is asking me, well, what do you want to plug port 1 into of the FortiGate? I want to plug it into the public subnet. And it tells me things like, well, here's your 2 subnet identifiers. Here's the availability zone that they're tied to. They're both tied to availability zone A. US East 2 is the name of my region, and A is my availability zone. If I recall correctly, US East 2 has 3 availability zones, A, B, and C. At least at the time that I made this recording, that was the 3 availability zones they had. Well, since it doesn't give me the name, only the identifier, there is another hint that I can use here. If I choose this subnet, the one that ends in 6 echo 07, 6E07, it has a CIDR block of 10010. That's the private subnet. I just know that from memory. If I didn't remember it, I'd have to go look. So if I choose this one, alpha 0170, it's using 10.0.0.0/24. That's my public subnet. That's what I want it to plug into. All right. Security group. Security groups are like layer 3, layer 4 access control lists or filtering mechanisms to filter traffic that's allowed to go into an EC2 instance or come out of an EC2 instance. It is stateful. When you create them or when you use them, they only have permit statements. They don't. The implication is anything that you don't permit is denied. So let's choose this option, create a new one based on seller settings. And so when you have this, basically in the marketplace, Fortinet has said, well, these are the ports that most people would want available inbound, and it creates rules, permit rules automatically. Let's call this FortiGate security group. And we'll just use the same thing for the description. There we go. And as you can see, these are inbound rules. And so I have port 22 available inbound for SSH, port 80 available inbound, port 443, 541, 3000, 8080, and they're all available with a source IP of 0000/0. So basically anyone, anywhere from any source IP can SSH into the FortiGate or bring up the HTTPS console. In the production world, that might not be ideal. Maybe I don't want anybody to be able to bring up my management console. However, for our purposes today, that will be fine. Let's go ahead and click Save. And now it says, which key pair do you want to use? This is the key pair that I just created a few minutes ago, lab-key pair. We won't use this on this particular EC2 instance in our lab. We will definitely use this when we create a Windows instance a little bit later, but every time you create an instance, it will ask you which key pair do you want to use. All right, that's it. Let me just double check my settings. T2 small, plugged into the public subnet with the security group that I just created, FortiGate security group. Click launch, and away we go. Now I need to go back to the EC2 console. I could click back to this screen and go there, or there's this nice shortcut right in the middle of the screen right here. Let's click that, EC2 console. All right, well, that deployed very quickly. It says it's running, initializing status checks. Let's just give this a name. We'll go to the name field. We'll call it FortiGate Lab1. There we go. If we go look at the bottom half of the screen, we can see information about this FortiGate. Which VPC it's plugged into, the Lab VPC. Which subnet it's plugged into, the public subnet. That is the only subnet it's plugged into right now. It only has one network interface. ETH0 is an elastic network interface or an ENI. If I click on it, we see this is the interface identifier, ENI-0F0B. I'm not going to read through the whole number. Just like everything else, right? It's got a really complex name, and the first three letters are usually an acronym to describe what it is. The IP address that it has on the public subnet. Now, you'll note here that it says private IP address. What that really means is the IP address within the VPC. This is not an IP address that you can reach from the internet to manage or speak to this ENI or this FortiGate. That's what they really mean by private IP address, is the IP address within the VPC. Let's go ahead and create a second port for this. As we recall from our lab diagram, this is going to have two ports, a port number 1 and a port number 2. Port number 2 is going to be another ENI that plugs into the private subnet. Let's go do that real quick. So we'll come down to network interfaces. Should be down here. There it is, under network and security, network interfaces. Very good. We can see the one ENI that was created by the marketplace launch a moment ago. You'll see it doesn't have a name. That can make it a little bit confusing. So I'm going to call this FortiGate public subnet, because once I have a few of these, it's going to get a little bit confusing about which one's which. By the way, if I really needed to know which one was which, I can always click on an ENI, look at the bottom half of the screen, and we have network identifier, instance ID. There it is in the bottom right-hand corner. That's the instance that it plugs into. And if I click on it, it'll take me over to that instance, and I can say, oh, this is the FortiGate. All right, let's add that second network interface. Create network interface at the top. Description. You'll notice it doesn't even give me an option for a name here. FortiGate private subnet. Which subnet do you want to plug it into? Well, I called it private subnet, so let's plug it into the private subnet. For its private IP, remember, private IP means the IP address within the VPC. Do you want to auto-assign one, or do you want to custom assign one and be able to type it in? I can use the auto-assign. It's going to randomly pick an IP address in the private subnet. If I choose custom, I can type one in, 10.0.1.100 / actually, there's no slash there. Think about that. There we go. And that would take it. Now, just for fun, let's choose an IP address that wouldn't work. Let's try to give it a public IP address, a public subnet IP in the private subnet, and just see what it does. Let's see, we'll also choose a security group, and I'll just go with the same FortiGate security group. So it's gonna have the same rules about what kind of traffic is allowed into or out of this elastic network interface if the traffic came in on the public subnet or the private subnet. I'll click create down at the bottom, and I got an error, which is exactly what I should have gotten, right? It says, hey, you can't assign that address. That's not in that subnet. So there is a certain amount of logic check that happens, keeps you from doing silly mistakes, because we're all human and we will all make silly mistakes. And there's no technical reason that I chose the custom IP. Auto assign would have worked just fine. I just want to demonstrate that functionality. All right, there's my second ENI at the top, and you'll notice that it didn't get a name. Let's call it FortiGate private subnet. Only let's fix my typo error there. There we are. All right, I've got one plugged into public, one plugged into private. And if we go back to our instances now, oh, you know what? I forgot to do something when I was on the other screen. Let's go back there for a second. Network interfaces. I created the private subnet plugged in ENI, but I didn't actually connect it to or attach it to my FortiGate. So there's a couple of ways that I could get to this menu. I could right click and choose attach, or I can go to actions and choose attach. They both give me the same options. Let's take the one for the private subnet, click attach, and it's going to ask which instance to attach it to. Pretty easy. I only have one instance, but fortunately it also gives you the instance name. There, we're going to attach it to the FortiGate. Now it's attached. I'll give that a second to complete. All right, finished completing there. Let's go back up to my instance list. And now if I look under network interfaces, you'll notice subnet ID still only says public. That's the primary network interface, or the first network interface that was connected to this instance is plugged into public. But if I look at network interfaces, there's two, ETH0 and ETH1. And if I click on ETH1, I see there's the ENI name. I see that it's using the private IP as 10.01.100. Very good. There's still some things that I need to do to edit that, but we'll come back to that here in a couple of moments. I would like to be able to reach my FortiGate through the internet and bring up its management console. In order to do that, I need a public IP address that is associated with ETH0, associated with the ENI plugged into the public subnet. It needs to be associated with that ENI, and the reason is that ENI actually has a route to get to and from the internet. Remember, I created this internet gateway a little bit earlier. Drawing tools, spotlight, here we go. I created this internet gateway a little bit earlier, and I created a routing table in the public subnet that says anything going to 0000/0 go out through the internet gateway. That's how things get in and out. There's no current internet route in my private subnet. If I take this public IP address and I associate it with port 2, or ETH1 is how that's described in the AWS console. If I associate it with ETH1, there's no route for that to get in or out to the internet, so it's not going to work. It needs to be associated with ETH0. So let's go create an elastic IP address, which is a public IP, and then we'll associate it with the first ENI. Go back to my regular mouse clicker, make that full screen again. Elastic IP addresses should be on the same screen here. Under Network and Security, Elastic IPs. There are none. Let's allocate one. There we go. I'm going to pick for any of the public IPs in Amazon's pool. Let's click Allocate. There it is. That's going to be my elastic IP. I'll note that a little bit later. Now, I've allocated it. Now I need to associate it with that one particular ENI. So let's say associate address. And by the way, I right-clicked and said associate address. I could have clicked actions and said associate address. No difference there. Let's go ahead and put in a name, FortiGate EIP, FortiGate Elastic IP, actions, associate address. Which instance? The FortiGate Lab1 instance. It's only one instance in the list. And in this instance, which private IP? This is tricky, right? It doesn't tell me the ENI. It tells me which IP address. Now, I could do this a different way, and I'm going to. Rather than associate it to an instance, I can say associate it to a network interface. And now it asks me which network interface. And I can say this one, which I gave the name earlier. Actually, I chose the wrong one. If you didn't catch that, I actually chose the wrong one. I chose the private subnet. Here we go. I want this one, public subnet, that ends in 08 alpha. There we are. And now when I see private IP, there's only one choice, the 10.00.226. Remember, 10.00/24 is our public subnet. It's been a while since I've tried to do it the first way. Let's say instance, just to try it this way, because I haven't tried it in a while. Private IP, there was a time when I believe if I tried to do it this way, if my instance had two network interfaces, it would give me an error. I don't know that it still gives me that error, especially since it has this nice drop down now that lets me choose one of the IPs. But I feel pretty certain that I'm going to get an error here that says you can't do it this way if your instance has two network interfaces. But let's just see. There we go. Yep, still get the error. It says there's multiple interfaces for that FortiGate instance. Choose the interface ID instead. Very good. Let's go ahead and do that. Network interface. And the interface that's currently on the FortiGate plugged into the public subnet. There's only one IP address to choose. Click associate. And it worked. Very good. That's something that you'll notice is kind of consistent in a few different places. There may be operations that you can normally do, and you can specify an instance as the target of that operation, of whatever it is you're trying to do. But if it has to do with networking, if the instance has two ENIs, two network interfaces, then you have to choose the network interface, not the instance. Just pops up in a couple of places, and you'll notice it here and there. If you're ever in that scenario, just look for the other option, and that should help. Right, very good. Now if I go back to my list of instances, I look at my FortiGate. There's my FortiGate. I look at the details about my FortiGate on the bottom side here. I look at ETH0 under network interfaces, ETH0, and you'll notice the private IP address, the one inside of my VPC, and a public IP address, the elastic IP address I just associated with that. You'll see this in several different screens, up in the top in the actual columns, right up there, IPv4 public IP address, or over here, public IP and elastic IP under this column over here on the right side. Sorry, I was just trying to highlight the right side column. It's really difficult to do. Public IP, elastic IP. There is the concept of a public IP address in AWS that is not elastic. The elastic IPs are static. So this IP address will stay the same as long as I have it deployed until I go and delete it. And I can reassociate this public IP to a different instance later if I needed to, or a different ENI. Versus a public IP address that's just public, it's not elastic, is dynamic in nature and cannot be moved to different instances. We don't use those at all in the examples in the lab, but they do exist. So just FYI, if you run into something that says there's a public IP, but it's not listed under elastic, yep, that's completely plausible. It's just not something we use in our lab example. Right. Well, let's go ahead and bring up that IP address and try to bring up the GUI. So I'm just going to click this copy to clipboard. I have a little header on the top of my screen. I'm not even sure if you guys can see that up there. I'm just going to move it. And we'll say HTTPS : //. So there we go. And by the way, whack whack. Nobody ever knows what I say when I say whack whack. How about // HPS:// I learned to call it whack whack somewhere in the 90s, and it's just stuck with me. Proceed. Normal certificate error for a self-signed cert. And it says, hey, this is a FortiGate. The default username is admin, and the default password is the instance ID. Let's click accept. It's going to prompt me to change it on my first login. Let's say admin is the username. We'll go back to my instance list. And the instance ID is just listed in several different places. It's at the top. I'm going to go right here, instance ID, because my browser puts this cute little copy to clipboard icon on it. That way I can just cut and paste, log in, and then I'm going to change it to something else. Because this is now a video, and if for some reason I left this running, everybody would now be logging into my FortiGate. Truth is, I'll delete this FortiGate long before you see this video, but just in case. All right, we can change these things later. I don't need to change the host name right now. Wonderful, I'm logged into my FortiGate. Let's go look at network interfaces first. Remember when this deployed from the marketplace, the only port that was initially associated or attached to this instance was the public subnet port, which is port number 1. Just to remind us that that's the public subnet, let's edit it and change some things about it here. We'll give it an alias, public. For the sake of it, we'll give it a role of WAN. We don't really need to change too much in here. It got an IP address from DHCP, 10.0.0.226. That will work just fine. We can see that HTTPS is turned on, SSH is turned on, ping is turned on. I won't actually be able to ping this IP address right now, at least I don't think I will. Let's give it a try. Ping. Well, I would never be able to ping 10.0.0 from my home, which is where I'm making this recording right now, but let's just try to ping the public IP, 18.219.9.85. Ping 18.219.9.85. I believe that this should not work, and we'll wait for a moment. And it does not work, just like I was expecting it not to. The reason that it's not working is, although I have ping turned on this interface, the security group associated with the ENI has ping filtered. There's no rule allowing ICMP. And this is something that I'm bringing up because if you are troubleshooting traffic flow to the FortiGate or through the FortiGate, keep in mind you can create policies and you can create administrative access in the FortiGate, but traffic never gets to the FortiGate if AWS has a security group filtering it out. So I'm going to go back to my instance real quick, and I'm going to show you guys something. If I look at ETH0, it'll say there's a security group. It's called FortiGate Security Group. So I am definitely probably filtering some traffic there. There's lots of different ways I can get to that security group and edit it. Security groups is located on the left side menu right there under network and security. It's also available on the right side over here under security groups. It says, hey, there's a FortiGate security group. Do you want to look at the inbound rules? Do you want to look at the outbound rules? Let's just look at the overall security group, and then we'll look at both sets of rules. Yep, there's my security group. It says the group name, FortiGate Security Group. There is the inbound rules, and these were created by the marketplace deployment wizard. Let's just edit this real quick. We'll add a rule. We'll say all ICMP from anything. Again, this is a lab. I'm not really worried about security. I'm going to delete this in an hour or two anyway. Click Save. Very good. Now, let's get this over here on the screen. There we go. Traffic pings are now working. Very good. All right. So always keep those security groups in mind. If traffic doesn't seem to be arriving on the FortiGate, AWS might be filtering them out. right, well, this looks pretty acceptable to me. I've just really put in an alias in there. That's the only thing that I've changed. Port number 2 doesn't have an IP address. Let's go edit it. First, for a role, I'm just going to go ahead and set it to DMZ, just for grins. I'm going to set an alias of private. And let's go down to address mode, DHCP. So I'm going to set this to DHCP so that it learns its IP address. It should learn the 10.0.1.100 IP. That's what I configured it for in the AWS console, or if the AWS console had randomly chose it with the auto assign option, that's the IP address it would get. Could I statically set the IP address using manual? I can. I could go in here and I could say 10.0.1.100/24, or if you prefer, like that. Either way would have worked fine. However, if I manually set the IP, now I need to make sure that I set it to what the console has, the AWS console, pardon me, has configured for it. If I set it to DHCP, the AWS console will simply automatically give it that IP address. That seems a lot less error prone to me, so that's what I'm going to do. I'm going to set it to DHCP. I am going to turn off this retrieve default gateway from server. Remember that in AWS, in the VPCs, there's an intrinsic router. It's the first IP address of every subnet, so it's the .1 IP address in a /24 network. And it wants to be the default gateway on every network interface. But in my topology, 10.0.0.1, the public interface can get out to the internet. That has a routing table entry that knows how to get out the internet gateway. The 10.0.1 network, the private network, should not have a route that gets out through the internet gateway. So I'm going to turn off retrieve default gateway from server. I don't want my FortiGate thinking that it can get to anything on 10.0.1.1, which is the gateway that it would learn on the private subnet. All right, very good. And just in case I want to be able to ping it from the inside network, from the private network, I'll turn those on. There we go. Now, I should be able to refresh and see this IP address. There it is. All I really did there was click on interfaces again so that it would refresh the output. You know, if that didn't work, if it still said 0000/0, I would have just refreshed my complete browser and that would have worked too. 623, in 623, I've noticed that I have to refresh the complete browser in order to be able to see that IP address. In 625, which is what I deployed, all I really had to do was click on interface and it refreshed it. So very good. Okay, let's go back to my diagram for just a second. I have some things that I want to be able to do. I want to be able to edit this private routing table. Let's get a pen going here. I want to edit this private routing table and tell this private routing table if anything goes into the private subnet and it's destined for the default route, which really means if it's destined for anything except for the VPC, send it to this ENI right here, the port number 2 or ETH1 on the FortiGate instance. That's a routing table entry I want to be able to make. There's two things that I need to be able to do that. First of all, I need to create the routing table entry. That's pretty easy. The second thing that I need to do really is done directly on this Elastic Network interface. There's an option on the ENI called Source and Destination Check, and I need to disable it. By default, AWS does not want to let you send anything into an ENI that is not destined for that ENI's IP. That ENI's IP is 10.0.1.100. So it just doesn't want to let you send anything into that that's not destined for 10.0.1.100. Well, if this Windows server wants to be able to get out to the internet to ping, I don't know, 8888, for instance, just use that IP address, well, then it needs to be able to put a packet into that ENI that's not for 10.0.1.100. So we'll disable source and destination check. Likewise, when 888 replies, it needs to be able to send out a packet that's not from 10.01.1100. The reply is going to be from 8888. So turning off source and destination check is necessary. And the easiest way to think about this is if you have an instance that's going to route, source and destination check needs to be turned off on the interface that you're sending packets to that are not going to be to the IP address of that ENI. Let's go ahead and delete all that drawing. Let's just say erase, put it back on my regular mouse clicker, and go turn off source and destination check and make that routing table entry. So we'll come back here. We'll go to network interfaces. This is a function of the network interface, not of the instance. So the first network interface up here is the one for the private subnet. I'll right-click that, change source and destination check, and disable it. Save. Now, if I forgot to do that, I'd be able to do all of the rest of the steps, and it wouldn't work. So if you've gone through all the steps, you've created the route table entries, you've done everything else, and it's still not working, go back and check that. It's a really easy one to forget. All right, let's go make that routing table entry now. So we're going to go back to VPC. We're going to go back to routing tables or route tables on the left. There it is, route tables underneath subnets. We'll wait for that to come up. There's my private route table. The only route in it right now is the one to the rest of the VPC. Edit routes. Add a route. Tell it if you want to go to anything else, right, a wildcard or a default route, then don't send it to the internet gateway. Send it to this network interface. Send it to which network interface? The FortiGate private subnet network interface. There we go. Click Save. Very good. Well, I have now my FortiGate set up. I've got my public side network interface set up, my private side network interface set up. I think we're ready to go and deploy a Windows instance into this topology. So we're going to deploy this Windows server that we see at the bottom of the diagram. Let's go do that. I'll go back to EC2. And I think there was actually a launch EC2 instance button on the VPC dashboard. I probably could have done it from there, but that's all right. I'm over here now. Launch instance. And let's just say Windows Server. Sure, Windows Server 2016 will be fine. We'll say select. It will ask us what instance type. I'm going to choose T2 Micro. It is going to make my Windows instance a little bit slow. I mean, it's one CPU, 1 gig of RAM. That's not a lot of RAM in 2020, but I'm trying to keep this as inexpensive as possible. So T2 Micro will work just fine. Next, tell me the details. There's going to be one instance. It's going to plug into Lab VPC. It's going to plug into the private subnet. Auto-assign public IP should be set to disable, which is the default subnet setting. Very good. Don't really need to change anything else about this. Once again, we get down to the network interfaces. It can auto-assign an IP address in the 10.0.1.0 network to this particular instance. I could hand type one in if I don't want it to auto-assign. I'm just going to let it auto-assign it. I believe there might be one more option that I need. Let's see. I think it asks me at the end. There we go. So we'll go next, add storage. The default storage for the instance is fine. I don't need it to be any larger than that. Next, configure security group. Let's go ahead and call this Windows security group. And that'll make it a little easier for me to understand later. We'll leave the only rule turned on. Actually, let's turn on two things. We'll also turn on HTTP. A little bit later, I will install a web server on this. I'm sure I'm looking right past it. There it is. I was looking right past it. And if I couldn't find it, I could always say custom TCP rule and set it to port 80, and that would have worked fine. But since there is a listing that says HTTP that sets it to port 80, we'll use that. Very good. Review and launch. And just a little bit of a review, look through everything. Yep, T2 micro. I feel pretty confident that I did everything correctly. Let's say launch, and there it is. It asks me which key pair I want to use. I'm going to say use the lab key pair that I used earlier. It makes me acknowledge that I have the PEM file for this because I'm going to need it. Launch the instance, please. There we go. Let's go to view all instances. I'm going to call this Windows Lab1. Now, when I look at the bottom half, there's a piece of information that I want. I'm going to go down to the ENI, the Elastic Network Interface, which is ETH0. I'm going to click on it. I need to know the private IP address, 10.01.89, 10.01.89. I'm going to use this. I'm going to create a VIP on my FortiGate to allow inbound RDP to this Windows instance. So we're going to go back over to my FortiGate. I'm going to log back in. And I don't really care about the host name right now. Let's go to policy and objects and create that VIP. Virtual IPs, create new VIP, give it a name, Windows RDP. Let's just call it Windows Lab1. Later, I'm going to use this for something other than RDP. What's the interface? This should be coming in on the public side interface. And the external IP is going to be the IP address of the public side interface. Keep in mind with your Elastic IP address, the Elastic IP address is destination NATed by AWS to this public ENI. So it gets destination NATed to 10.0.0.226. The FortiGate doesn't have any visibility to the Elastic public IP. When the packet arrives on the FortiGate, its IP address is not 18.219.9.85. That has already been destination NATed to the 10.0.0 IP. Let's go ahead and do this, 10.0.0.226. For those of you who are paying attention, I could have left it to 0000, and that would have been fine too. This definitely needs to be the internal Windows IP, 10.0.1. And I've already managed to forget what ETH0 was, 10.01.89. There we go, 10.01.89. I only want this VIP to work for RDP traffic. I could do port forwarding, and I could say external traffic on 3389 gets mapped to 3389 internally. That would work. Or I could say where the service is RDP, there we go, and that would work. What I don't want to do is simply leave it like this, because what would happen is all of the traffic to 10.0.0.226, as long as it passed policy, would try to be forwarded and destination NATed to the Windows system. And that would mean that I would lose my ability to SSH into my FortiGate and bring up the HTTPS console onto my FortiGate. So in my scenario, that's the only ability that I have to reach this FortiGate is through that 10.0.0.226 IP. So let's just make sure that we're only doing this for RDP. And I'll choose port forwarding just because. Either one of those would have worked just fine. But that way this VIP only works for 3389 traffic. There we go. Now let's create an inbound policy. This is a FortiGate like any other FortiGate you've ever seen. The only policy by default is policy 0, the implicit deny. Windows inbound RDP, name the policy. This course is really not about configuring FortiGates for things that you might have learned in NSE4 training or even in like enterprise firewall, NSE7 training. So I'm not going to go through a lot of detail on creation of the policy. There's other training classes that you could that you could participate in to learn those things. Source IP address or source address object of all. There we go. Destination address object of the VIP. There we have it. Service. We'll just make this as specific as possible. RDP. Accept the traffic, inspect it in a flow base. I don't need to source NAT inbound traffic. It can look like it's coming from the internet. I'm not going to turn on any security profiles. Let's go log allowed traffic all. For the sake of troubleshooting, when I'm setting this up for class, I do like to say generate logs when session starts. If I've done something wrong and it's not working, I can see that traffic is arriving. It's just not getting replied. That can be really helpful for troubleshooting purposes. Normally in production environments, I don't leave that on all the time. Generate logs when session starts. Click OK. Very good. MSTSC. I'm going to bring up the terminal server client now. I'm going to put it over here. And this is going to be 18.219.9.85. I'm going to click connect, and it's going to fail. Now, why is it failing? I'm going to give this a few seconds. I want you guys to think about this. Why is it failing? Here, let's troubleshoot a little bit. Diag sniffer packet port number 1, the public side port, and then port 3389, which is RDP. Verbosity level of 1 should be fine. All right, I'm sniffing for port 3389. Nothing's working. Well, RDP traffic's not showing up. Nothing's working. Obviously, I'm able to talk to my FortiGate. I have connectivity to that IP address. Just double check my IP, 18.219.9.85. Yep, that's the right IP address. What did we say filters out traffic? You have to have a permit statement. Right. We have to go and edit the security group. So I'm going to go to the security group for the FortiGate. Now, the Windows security group does allow port 3389. Yep, it sure does. But the traffic goes through the FortiGate first. So I need to edit the FortiGate security group. So I'll click on the FortiGate. There's lots of ways I could get there. Rather than clicking on FortiGate security group, let's go to view inbound rules, just because I showed you the other way earlier. And look, 80, 541, 80, 80, 22, 3000, 443, ping, ICMP. There's no 3389 in there. Okay, well, let's go to the security group and allow 3389. And there's my FortiGate security group. By the way, I have more than one security group, but only the FortiGate is displayed because it filtered it. When I chose to click on that, it took me to the screen and it filtered for just the FortiGate. I'm going to take that filter out of the top because I want you to see that there's more than one in this. So can't really scroll very well. Can I move that? There it is. Move that down. Yeah, I've got the FortiGate security group, the Windows security group. Let's edit the inbound rules of the FortiGate security group. Edit. Let's add a rule. I could say custom TCP rule and choose 3389, but there is a pre-built rule called RDP that just does TCP 3389 for me. And we'll just do 000/0. Very good. Save. All right, let's try this again, but let's go back to our FortiGate and see. All right, well, my sniffer already starting to show some traffic showing up. Yay. All right, so the traffic's making it to the FortiGate. It's prompting me for username and password. The Windows instance username and password we have to get from the AWS console. So let's go back to my list of instances. Let's go Windows Lab1 instance, right click on it and say get Windows password. In order to give me the Windows password, I'm going to have to submit my PEM file for the lab pair. Let's put this over here, downloads, AWS key pair, there it is, lab key pair PEM. And now I can choose decrypt password. Username is administrator. Password is this handful right here, which I'll just copy and paste. So let's say more choices, use a different account, administrator, actually local host / administrator, just so it doesn't try to submit my domain as the domain. And then we'll paste the password in there with the little eyeball icon. There it is, yep. Click OK. Very good. While that's coming up, I'm going to go revisit my FortiGate because I'll be frank with you, that T2 micro instance that I used earlier is going to be really small. It takes a long time to, well, it doesn't take a long time. It takes a few seconds to bring up the console, the GUI of Windows. Let's go ahead and click close there. Let's go look at the FortiGate. I don't need to see anymore. This is my traffic flowing in and out. Let's just hit Control C. As you can see, my public IP address is the source coming in. It's hitting 10.0.0.226, and then we should see the traffic being forwarded. Actually, we're not going to see the traffic being forwarded because I filtered this to only show me port 1. So very good. Let's go ahead and close this. We don't need it. Let's refresh my policy list. And I see some bytes on the policy. I could go under log on report, look at forwarding traffic, and I could see that traffic was flowing through Windows inbound RDP. Very good. All right, that part's working. This is probably a good time to take a break. So I'm going to pause the video for a few minutes, get a cup of coffee, and when we come back, we'll work on outbound access. Outbound access. All right, talk to everybody in a few minutes. Okay, I hope everybody had a good break. Now we're going to continue on to the next part of the lab. So for our outbound access, we're going to take the topology that we just configured a few moments ago. And for the outbound policy, to do something kind of interesting, we're going to create a dynamic address object that uses the AWS Fabric connector to be able to automatically include IP addresses of devices in the private subnet. And this could be useful in production scenarios. Perhaps you have database servers that you want to have particular policies that have outbound access to the internet, but for particular things. And then you have other servers like web servers that you want to have different policies tied to them. And dynamic address objects that only include database servers or only include web servers could be kind of interesting. So let's go ahead and create the Fabric connector. And then we'll use the Fabric connector to create the dynamic address object, and then we'll use the dynamic address object on an outbound policy. Now, just to confirm that we don't have an outbound policy yet, admin, log into the FortiGate, and while we're logged into the FortiGate, we'll pull up the Windows system. Just a moment, I'm going to disable the Internet Explorer Enhanced Security Package Manager. There it is on Windows Server. And this has nothing to do specifically with our lab. If you use Windows Server very much, I'm sure you have realized that by default, the Internet Explorer Enhanced Security configuration will basically stop you or make you confirm before you go to any website, and that can get a little bit annoying in a lab. So I go into Server Manager, Local Server, IE Enhanced Security Configuration, and I'll just say off and off. And for lab purposes, I don't have any problem with that at all. And then we'll close Server Manager because I don't need it for anything else. We'll launch Internet Explorer. Yes, that's fine. Recommended settings are just fine. And we'll just say, go to Fortinet. And as long as I have done my job correctly, it should not be able to go there. The VPC private subnet routing table has a routing table entry that says, if traffic is destined for anything outside of the VPC, send it to the FortiGate. And the FortiGate will be matching this to policy 0, to the implicit deny policy. Because on the FortiGate currently, there we go. If we go to IPv4 policy, policies and objects, IPv4 policy, there is no outbound policy. There's an inbound RDP policy and the implicit deny. And everything that's not inbound RDP is hitting the implicit deny. So there we go. So we've confirmed it. It's doing what we think it's doing. It's not allowing internet traffic. And now we're going to go and work on that. If we're going to use the Fabric connector is going to need to be able to effectively log in and authenticate to our AWS cloud. So I need to create a credential. I'm going to go to Identity and Access Management, IAM. Oops. There it is, under Security, Identity and Compliance, Identity Access Management, IAM. Wait for that to come up. Very good. We'll go to users. There is one user right now that my firewall at home uses. I'm going to create a second user. And just to be able to understand what this is later, I'm going to call this Lab FortiGate. That way I can easily identify it to delete it later. This is going to be used for programmatic access. So my FortiGate will use the API to log on to the console or log into the AWS cloud more specifically and get IP addresses of resources. Next, permissions. I can say attach existing policies directly. There's a couple of different ways that you can do this. And if you ever take the full course is doing this for a lab. And for simplicity of a lab, they simply have you give this user, this API user administrator access. And while that is functional and does accomplish the lab, it seems a little bit reckless to give an API credential full administrator access. So instead, what I'm going to do is look down in this list to see what else is in here with read-only access that might work. Let's see. I saw it on EC2 read-only access just a moment ago. EC2 read-only access. And I believe this will work. I've used it before. It is one of the built-in existing policies. Yeah, list EC2 instances, CloudWatch, full list read. Yeah, there we go. I believe this will give me enough permissions to be able to read IP addresses, which is really all that my Fabric connector needs to be able to do. Certainly, if this failed to work, I could go back and use administrator only, or I could get a little bit more granular and create my own policy and then give that policy exactly the permissions that it needed. But I believe for my purposes, the EC2 read-only access should be sufficient. All right, let's say next tags. I don't need any tags. Review. Yep, there we go. There's going to be a username called Lab FortiGate. It's going to get EC2 read-only access, create user. Now I need my credential. So let's just open up Notepad. Something simple here. And first, let's get the access key identifier. And then we'll get the secret access key. And I'm going to show you guys this, but only because I plan on deleting it long before this recording is ever viewed by a human being. There we go. So there we are. Those two pieces of information will be needed on the FortiGate. Now let's go back to the FortiGate. We're going to go under Security Fabric, Fabric Connectors, and depending upon the version of FortiOS you're using, the option for Fabric Connectors is moved around a little bit. But once you get there, the option is pretty consistent. Let's go ahead and click Create New Fabric Connector. It's going to ask me what kind. I'll choose the AWS. There it is, AWS, top in the list. Let's call it the Lab AWS connector. And it says, well, how do you want to authenticate? Use metadata. So we don't use this option in this particular lab, but just so you're aware of what this use metadata option is, a moment ago, you saw me create effectively a user credential, and that user credential had rights based on a policy. That particular policy was the EC2 read-only policy. Imagine, if you will, rather than creating a user credential and giving it rights, I gave the EC2 instance rights directly. And then the EC2 instance, a query that came from this EC2 instance, by virtue of coming from the EC2 instance, would have those read-only rights that I gave earlier. That's what metadata IAM is about. It's about being able to give the instance itself rights or privileges in the AWS cloud. This would only work if the Fabric connector was being configured on my AWS cloud-based FortiGate. I can't give my FortiGate that sits at the edge of my data center metadata rights because it's not an instance running on AWS. So I actually prefer to give you the example that I am giving you because you can use this to create a credential for any FortiGate anywhere to go talk to AWS. There's various purposes for wanting that. So I'm not going to do the metadata option. It says, okay, well then give me the access key and the secret. Well, fortunately, I jotted those down. Control C, Control V, there we go, paste that in there. Control C, Control V, we'll put that in there. This is the US East 2 region, Ohio, if you recall. And I could filter this down to a particular VPC. This has changed a little bit over different versions of FortiOS, exactly how far you can filter this down, but I believe I can make it connect with just that. So if I refresh, oh, it says it's down. I might have goofed up there. US East 2. Let's go get the name of my region. We'll go back to services. Should be fine here. US-East-2 is the name of the region. I wonder if I need to East 2. Hey, there we go. Honestly, I don't think I remember that was case sensitive, but indeed it is. Lowercase US East 2 worked, uppercase US East 2 didn't. Just for grins, let's just go back to that for a second and say US-East-2 and make sure it wasn't just a timing issue. Make sure say hit OK there. Yeah, sure enough, case sensitivity matters. I don't think I remembered that. US East 2, very good. And if I hit refresh, green arrow should be back. There we go. So I've got a green arrow. It's able to go log on through the API. Now we should be able to create a dynamic address object. So I can go to policies and objects, and dynamic address objects are really like any other address object. You go to addresses, you click create new. Any of the various ways you could go to create an address object, because there's lots of ways to get there. You can create a dynamic one. It's just a particular option when we get here. Instead of subnet, we say dynamic. And again, depending upon the version of FortiOS, if you're back in 6.0, the type is a little bit different. The choosing of the submenus varied just a little bit. But once you get that type chosen, the rest is going to be the same. Let's call this Windows RDP. Actually, we'll just call it private network. There's a couple different ways that we can do this. Which connector do you want to use? Well, I only have one connector, so let's just choose that connector. Great. What type of address are we going to make for this address object? If I say public, it could do things like elastic IPs. If I say private, it's going to be the private IP address within the VPC. All right, great. Well, how do you want to filter this? There are several filters available to me. I can say things like all of the instances that are T2 micros, all of the instances that are T2 smalls, all of the instances with this instance ID or with this instance ID, all of the instances that use the lab key pair. That's kind of interesting. All of the instances that use a particular security group. And it is noteworthy that for all of these things, I'm seeing the object or the resource identifier, not the friendly name, right? You're not seeing FortiGate Lab. Now, I do have these friendly names, tag names. The name field is actually a tag, and you can use those tags within things like filtering for a dynamic address object. You'll also notice that in various wizards, you can add a tag to an object like an EC2 instance or an ENI. So all of my database instances, I could tag with the word DB. And then I could create a filter that said only include the objects that have the tag DB on them or the tag web or whatever was appropriate. I just want to include Windows, so I just say everything with the tag of Windows Lab1, which is just my Windows system. So private network, let's actually name this Windows. Okay. And initially, it should have a red bang on it, and it'll have a red bang on it for, I don't know, a few seconds. If I'm going to click addresses and refresh it. There we go. And then once it doesn't have, there we go, we can see that it resolved to 10.01.89. I'm going to go and create an outbound policy using that address object. Windows outbound. Coming from the private side, going towards the public side where the source is Windows. The dynamic address object Windows. Right? And the destination is, and this is just to allow internet traffic, so we will simply say all, and we will only let HTTP and HTTPS out. Flow-based. Now I will let this source NAT on the way out. Let's say log all sessions. I'm not going to do when session starts. I'll click OK here, and we'll talk about why I did source natting. Let's go back to the topology diagram to discuss why I turned on source natting. Sorry, looking for the lab diagram that we were using a little bit earlier. I have lost track of it. Here it is. Too many windows open. Very good. Let's go ahead and give myself a pen again. This subnet has a route that goes out to the internet /0. And when traffic routes out, if it is from the IP address assigned to this interface, right, which I believe was 10.0.0.26 or 226. I don't remember the exact IP address. Let's just take a quick look. To go back and say, give me my pen and network interfaces. .226. There we are. .226. Let's go back to the pen here. Drawing tools, pen. 226. It has a route out through the internet gateway. And because it came from 10.0.226, the internet gateway will source NAT it to the elastic IP. That was that 18 address, the address that we're using to get to and from everything in the lab. So only 10.0.0.226 can get source or destination added to the elastic IP address. So we are going to source NAT this as it leaves port 1 to go out to the internet. And as it goes out to various websites and it comes back, it'll come back to the elastic IP. The elastic IP will destination NAT it back to the FortiGate. The FortiGate is a stateful device, so it will remember the state of the session and reply it back to the Windows server. But we have to source NAT it to 10.0.0.226 or to whatever port 1's IP is as it's leaving the FortiGate. Let's go ahead and erase all of these drawings and go back to my click here tool there where we are, minimize that down, go back over here, and unable to open the page. Yeah, I know. Well, there you go. By the time I clicked OK to that, it just binged that and went, yep, I can get there. Fortinet.com. There it is. And we'll go to Google, because I don't think Bing would do this. Oh, come here. Google.com. And I'll just say, what? There you go. So as Windows is going out through the FortiGate, it's getting source NATed to the FortiGate's public side IP 10.0.0.226, and then as it goes out through the Internet Gateway, it's getting source NATed to the Elastic IP 18.219.9.85. Very good. That is an outbound policy using the dynamic address object.